do we get this toolbar to go away? There. All right. So the operators, we know what these mean since elementary school. Greater than, less than, greater than or equal to, less than or equal to, plain old equal to, and not equal to. There's only one subtlety involved in these guys. Guess I need to fire Windows back up so I can start taking notes. Which is, what is the opposite of what? If you're checking to see if something is greater than 100, what's the opposite of that? Checking for less than 100? No. Checking less than or equal to 100 is the opposite. Right? Because if I'm checking to see who's greater than 18, greater than means 18 doesn't count, right? So if I'm only letting people in who are greater than 17, the people who can't come in are, did I say that right? Let me type some notes. And I'm not sharing my screen. That would be a problem. Thank you. Please stop telling me to update Windows. All right. So starting a new program. We run lecture G. I'm going to scream if you don't stop trying to update. All right. So here we go. If we have this, right, we're going to check to see if somebody's of drinking age, right? They have to be 21 or older. So bool, DA for drinking age is equal to age greater than 20, right? Because 21 or older are too young. 21 or older is fine, 20 or less is not. So let's declare a variable for age, you know, whatever they want to type in. We could use an input statement on that, but making an input statement at the very beginning of class means I have to answer it every single time, right? So if we're of the drinking age, then we're just going to say DA is equal to true because we're not really trying to recommend people go out and drink. All right, I need to add my using namespace std. Change that to cout, and we should be good to go. Trying to get it so that I can see the toolbar as well, so I know if anybody sent any chat messages. I may not be able to accomplish that with any great aplomb. Could start using the Mac version. Anyways, okay, now I think it's good to go. All right, so I should be able to see your chat messages that come up. All right, so now I'm going to declare another variable called LDA, meaning less than the drinking age, right? Bool LDA equals age is less than or equal to 20, right? So if you're going to check to see if something's greater than a value, the opposite is less than or equal to that value, right? So opposites, the opposite of greater than is, of course, less than is greater than or equal to. The opposites of less than are greater than or equal to. And how about equal to, right? You have your double equal sign. Then the opposite of that is not equal. That's an exclamation mark. So like if they type in a string, we could check to see, right? If the choice was not equal to Y, then do something, whatever, right? Why not? See out, why not? Here we go. I'm gonna go back up, and you know what I'm gonna do? I'm gonna use my fancy schmancy new boilerplate up here, which has got a lot more pound sign includes in it. It's got some we haven't even started using yet. We haven't used IO manip. And yet it doesn't have the one for random. Oh, well, I need to make a better one still. But this will start us off. All right, so at least it's got string and IO stream, and accidentally deleted the using namespace std. All right, so if I wanted to run it, I could. I'm expecting you to say, why not? No, wait, it's not going to say why not, because choice is equal to y, right? So said DA is true because 25 was in fact greater than 20, but it didn't print the other message. If choice is not equal to y, then print why not, else C out. Okay, great, right? Now, if you can write your logic in such a way that you can avoid using that not indicator whenever you see the exclamation mark, use not, I would do so. So I would rewrite this so that if it said if choice equals yes, print okay, great. Just because the way that our brains are wired, it's not to help the computer, it's to help us program, because the way we think, you know, it's like when you start using double negatives and triple negatives and our brain gets, you know, twisted around trying to understand it. It's easier for us humans to comprehend it if we're checking for the positive rather than for the negative in most of the time. So normally what I would do is I would rewrite it like this. If choice equals Y, then C out yes, else C out no. Sad face. All right. They both do the exact same thing. Well, other than the message that they're printing, right? I could make them print the exact same message if I so chose, right? I could do some copying and pasting. They do the same thing. It's entirely up to you how you like to see it. So expressions. 12 greater than 5 is in fact true. 7 less than or equal to 5 is in fact false. Okay, no mysteries there. Do not confuse a single equal with a double equal. And that's very important, because if you do that, then you're liable to just erase the value that you're testing, right? Oops, messed up there. What if I was could have checked to see if somebody was 18? And so I did this. If age equals 18, C out happy 18, whatever, right? You can vote and stuff. So I use a single equal here. And that is a mistake, because no matter what we set it to, unless we set it to, yeah, no matter what we set it to, it's going to say happy 18. And then when we print out the value of age afterwards, it's going to say that the age was 18, because this erases it. That equal sign says copy this value into that. It doesn't matter that there's an if in front of it. It just copies the 18 into that. Erases the former value of age. And then after that, it checks to see whether this expression is true or not. And what it does in the case if it's just a number rather than a Boolean value is it just goes, okay, if it was 0, it's false, but any non-zero value is true. And since age is 18 at this point, it's going to say that's a non-zero value, and so it's going to print happy 18. See if that's correct. Right? Happy 18 age. So if you use single equals when you meant to use double, it's going to erase your data. You might get a warning about it if we look at the error list. See, it's not even giving me a warning. It doesn't care. The languages like Java and Python don't let you do that. But C++ just goes ahead and lets you do it without warning. So don't confuse equal, which is the assignment operator, with equal, right? Which is the, equality check. They may give it a different name, but you know what it means. The if statement. We know what if statements are. If it is raining, take an umbrella. If it is cold outside, wear a coat. Logically, is it cold outside? Sure is. Wear a coat. Is it cold outside? Wear a coat, wear a hat, and wear gloves. If you're going to chain multiple statements under an if, you have to use braces. Here I didn't. Here I only had one statement. But if I needed multiple statements, I would need to use curly braces. So we're going to say happy 18, now see out, now go out and vote. Right. So since this is a block of code consisting of more than one statement, we did have to use the curly braces. If it's only one line long, the curly braces are optional. I like seeing curly braces, but when I'm putting code on the screen for you to read, since my font is large, I can't get that much that's visible. So sometimes I leave them off. The general format, if, parentheses, logical expression or Boolean variable, followed by the statement or block of statements. If the expression is false, it skips it. If the average is greater than 95, display congratulations. That's a high score. How many examples do we need? If statement notes, never put the semicolon after the expression. It kind of disables it. If I did this, if age is greater than 0, semicolon, and then I did C out, yes, age is greater than 0, like that, it is going to print this. Absolutely. But if I make this a false statement, right, like if I set age equals -1 here, it's going to check to see if age is greater than 0, but it's going to go ahead and print this anyways. So we're going to see age is greater than 0, even though it's obviously not. Why? Because by putting a semicolon there, here's what we really mean. If age is greater than 0, do nothing. And then, oh, by the way, we have another statement coming up. But see, this is not part of the block of the code. All it's like is that we went in here and we took, that out. If choice is equal to y, do nothing. So pretty much anytime you have a semicolon, if the semicolon is in front of a curly brace, it's going to be an error. You never see a semicolon in front of a curly brace. So right here, it would have been kind of obvious, but not really. If we had this, right? It's a kind of a subtle error at first, but there are people who argue that you should put your opening curly brace on the same line as the line above it, and then it becomes obvious, really obvious, right? That's the wrong syntax. And that's the only argument I know for putting the curly brace on the same line as the if, except for the fact that it also lets you squeeze more code on the screen, which usually isn't a factor. Just is in my demonstrations because we're trying to get more code on the screen still. I like for my curly braces to line up. Don't do this because this will print no matter if the if is true or false. Same is true for while statements. If I do this, while age is less than 10, semicolon, see out, you know, something, see out the age variable, it doesn't really matter what, and then add 1 to age. It looks like a good loop. It looks like it'll keep printing, you know, the age up until 9. Or if we make it while age is less than or equal to 10, it looks like it's going to count up until age is 10. Instead, it's going to be an infinite loop. So when I run it, I'm not going to print anything. It's just going to hang. The reason it's hanging is, again, because what it really means is this. While age is less than 10, do nothing. And age is, in fact, less than 10. We set it equal to -1, right? So nothing ever changes the value of age here, so that's an infinite loop. So I'm just going to make a comment here and then comment all of this out, right, because it breaks the code. The semicolon makes it an infinite loop. Expanding the if statement. You can have if else. You can have if else if else. If you've taken Python, you're used to using elif like this. You know, if total is greater than 0, do something, you know, print something. Elif total is less than 0, do something else. Else print wow total equals 0, right? Because that's about the only third choice. Anyways, C doesn't work that way. C, C++, C#, Java did not work that way. You use the else if keyword. And honestly, I don't know why Python invented the elif keyword. I've never seen that in another language. So expanding the if statement. If your grade is greater than 90, this makes a block of code. If the expression is true, it'll do the first thing. If the expression is false, it'll do the second thing. So the expression is evaluated. It could be a Boolean variable. It could be an expression like if age is greater than 18, or it could just be a number. And if the number is non-zero, it will go ahead and do that. But most people don't do it that way. They use Boolean expressions or values. So if the number modulus 2 equals 0, if you divide the number by 2, is the remainder equal to 0? If it is, print that it's even. Else, print that it's odd. So we could make a loop that would print only even numbers pretty easily. It's certainly not the only way to do it, but we can. Let's create a counter. And we're going to keep going while the count is less than or equal to 20. But we only want to print even numbers. So I'm going to do that if statement. If count modulus 2 is equal to 0, then that means it's equal. We divide by 2, the remainder is 0, so we're going to see out even. How about we print out the words is even, \n. And then we could do an else. Oh, come on. Else colon. Oh, no. Now that I did some Python, I'm wanting to put colons in, and that's not right. Is odd, \n, in quote, semicolon. And so we could just print out the number first, right? See out count, and then it's going to print it's either even or odd. And what I forget to do, it's an infinite loop. I made a mistake, and that one actually wasn't intentional, but that's okay. This isn't even the loop chapter, but We know what loops are. The problem with the loop is that we never update the condition. And so since count is true to begin with, it stays true. Nothing is ever changing the value of our count variable. So let's add 1 to it. And there, it printed out 1 through 20 and whether they're even or odd. We could expand upon it further so that we check to see if it's divisible by 3 or not, right? So I'm just going to copy this statement, but change it to see if it's divisible by 3, right? So if count modulus 3, we're going to say is divisible by 3 \n. And here we're going to say is not divisible by 3 \n. Now the format's not going to look perfect and all that, but that's okay. You'll see what I mean by that. We run it, right? It says is odd, is not divisible by 3, right? Maybe if we put some parentheses or something to indicate, to make these visually separate from each other. We could try to write some really complicated one that would use the and. In fact, as a matter of fact, I think we could just do and. And since we know it printed one thing or the other, it'll be okay. I think that output's going to look okay now. All right. Kind of looks like garbage. I don't have a \n in there somewhere. That's because I just have in rather than \n. Run it one more time. Right. 3 is odd and is divisible by 3. 4 is even and not divisible by 3. 9 is odd and divisible by 3. 6 is even and divisible by 3, and so on, right? So now we understand what if and else do. And again, if it's a block of code, you have to use the curly braces. Nested if statements. An if statement that is nested inside another if statement is called a nested if statement. So for example, if you're 18 or older and you are a citizen of the United States, you're allowed to vote. So let's set age equal to 18 again, right? Or something above 18. And let's declare a variable called citizen, right? Or we could just make it a string, right? Like they just typed it in. So if age is greater than 20, if citizen equals quote y, too bad we're not checking for lowercase y's. If we wanted to also check for lowercase y's, we could use the or symbol. 2 vertical bars, which is the shift \, the key under delete and above return means or. Like that, right? Is there another way to check that? If I type in citizen dot to get a list of commands that work with citizen, do any of them check without case? No. That's all right. Okay. So if citizen is equal to y or the citizen is equal to lowercase y, I need to get rid of that statement now. Then we're going to see out, congrats, go vote. But if they're not, let's tell them what's wrong. I'm going to take these braces out, but I'm going to leave the other braces in. Maybe it'll be clear why. Sorry, must be a citizen to vote. And then down here, we're going to put our other else. Oh, it was supposed to be greater than or equal to 18. I don't know what I was thinking there. Taking away somebody's right to vote there. So else, cout, sorry, you're not old enough to vote. Okay. So in this case, if we run it, we're going to see this message that says, congrats, go vote. But if we change either one of these so that the case becomes false, like if we change them not to be a citizen, we'll see either that message, or if their age is not greater than or equal to 18, we'll see this message. So this is a nested if, which is just an if inside an if. Sometimes you can replace a nested if with the and symbol. If that means or, two bars, sometimes people call them pipes, right? Means or. Two ampersands means and. So sometimes you can use and to replace nested ifs. We could do this. If age greater than 18 and, wait, this isn't Python. I have to use the abbreviation. And citizen equals quote y, or citizen equals lowercase y, then we can print out a message. Congrats, go vote. Else, and I'm going to take the curly braces out to save space. As long as you can read it, as long as you understand what I mean. Else, cout, sorry, must be a citizen and over 18. All right, now I actually did not write this correctly. And the reason why is just like math. If you do this, x is equal to 1 times 2 plus, 1 plus 2 times 3. What is that equal to? We've already talked about it. You don't say 1 plus 2 is 3 times 3 is equal to 9. That's not correct. Why? Because ampersand has higher priority. It's got higher operator precedence. So does, I don't know if I said that right. Multiplication has higher operator precedence than addition, right? It's like elementary or junior high math or whenever we learn that. Ampersand has higher priority than or, for reasons which I'll explain in a little bit. So I don't want it to do this part first. I want it to do this part first, right? I want to check to see whether citizen is correct or wrong. So I need to put that inside parentheses to get it to go right. All right. So now we only have 2 possible outcomes rather than 3, but I think that's okay, right? Here we had 3 possible outcomes because we had an if, and then we had a nested if. And so the inside here, we had 1 of 2. And then out here, we had a 3rd possibility. Now we've only got 2, but I think that's okay. I think it's just as clear. Code's a little bit clearer, right? This took like 10 lines of space, and this only took 4. So if you don't need to produce quite as many output statements, if you don't need the 3 choices, and that would be the way that I would do it. Nested if can sometimes be replaced with and, which is 2 ampersands. So what does and or technically mean? And means both sides have to be true, right? If sick and tired, stay home. I have to be both sick and tired to stay home. I can't just stay home because I'm tired. I have to be both sick and tired. I can't stay home just because I'm sick. I have to also be tired. Now that's silly. Maybe that's fair, maybe not. Let's change it to or. If sick or tired, stay home. Now I get to stay home if I'm tired or sick, and hopefully my boss doesn't catch on that I'm taking off so much time just because I'm tired, right? Or means one or the other. So or returns true if one or the other or both are true. You can make what's known as a truth table for it, which looks like this. X and Y and the result. And if you're using or, you're using your two vertical bars to mean or, then it looks like this. If you have a false and a false, then the result's going to be false, right? If you have a false and a true, the result's going to be true. If you have a true and a false, the result's going to be true. And then if you have a true and a true, the result's going to be true. Now that's the or truth table. The and truth table looks a little bit different, right? Because it means something different. And means both sides have to be true for the result to be true. So like if you have money and your hunger is greater than 0, go out to eat, right? If you don't have any money, you can't go out to eat unless you have a credit card or you're borrowing money, right? If you're not hungry, there's no reason to go out and eat. So both of these need to be true. Let me put quotes around this so it's a little bit clearer. So and returns true only if both clauses are true. Both sides, both operands. So if that's the or truth table, let's redo it for the and truth table. So I'm just going to copy and paste a little bit. Change this to the and symbol, the shift of the 7 key. And what are our results now? Well, they both have to be true, so only one of these cases is going to be true. And that's that one. The rest of them are false because they both have to be true for the result to be true. Now I'm going to tell you why this has higher operator precedence than or. Now, what if you looked at this and we replaced the falses with zeros and the trues with ones? So I'm going to replace all the F's and falses with zeros and all the trues with ones. Where'd it go? Did I just delete the whole thing? And what about the other one? Going to do the same thing for and. Replace all the F's with zeros and all the T's with ones. I swear, if I could disable the trackpad completely, and I knew how to do that on Windows, but I don't know how to do it on my Mac, I would do so. Because as I'm mousing, as I'm typing, my hand sometimes touches the trackpad, because on this laptop, the trackpad is the size of a football field, which seems great until you keep triggering it accidentally for me. All right, so 0, 0, 0, 1. All right, now let's look at it. This, I guess I haven't changed these yet. I thought I changed them all. All right, so 0 plus 0, excuse me, 0 times 0 is 0. 0 times 1 is still 0. 1 times 0 is 0. And 1 times 1 is 1. So and is akin to logical multiplication. And as a matter of fact, if you take a logic course, sometimes you will see multiplication used as a symbol to represent and. Well, that probably means that or is akin to logical addition. But let's test it out. Putting that in the wrong place. I changed the wrong and. Oh, for Pete's sake. I knew I'd already changed it. And then when I scrolled up, I lost it. I wonder if I still have this in my copy paste buffer. Nope, of course not. Sorry, guys. Don't go to sleep. All right, now I need to go move this message to where it belonged down here in the zeros and ones example. And here we go, right? 0 plus 0 is 0. That's the only time OR is false, or 0. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1, well, you'd think it was 2, but really in this kind of math, there's only 2 possible values. There's 0 and not 0. So we're going to say that 1 plus 1 equals 1. So OR is akin to logical multiplication. Now, why did we take 5 minutes to type all that? Just to remind you that AND has higher precedence than OR. Wait, that was addition. AND has higher precedence than OR because multiplication has higher precedence than addition, which is why when I was writing my if statement up here, I grouped this inside parentheses, just like I would group them if I needed to do some addition, right? If I was doing some multiplication and division, I might need to use parentheses, right? So x is equal to 2 times 3 plus 4. If I wanted the 3 plus 4 to happen first, I have to have the parentheses. If I don't, then it's going to say 2 times 3 is 6, plus 4 is 10. But 2 times 3 plus 4 is 14, because 3 plus 4 is 7 times 2. So just like you can use parentheses, to group math expressions, you can also use them to group logical expressions. All right. So nested if statements, are you employed? Yes, I am. And are you a recent grad? I sure am. Display you get the special interest rate. If not, display, sorry, you must have graduated recently. But if we weren't an employee to begin with, our else is, sorry, you must be employed to qualify. Now this is a nested if. Excuse me. So nested ifs can be replaced with ands sometimes. And if we did that, we would say if employed equals yes, Y, and recent grad equals Y, then display congrats, you qualify for the special interest rate. Else we tell them why, right? We say, sorry, must be employed and a recent graduate or graduated within the past 2 years. That's kind of just a binary choice, right? With only one of 2 possible messages. We tell them, yay, you got it, or no, we display a message that tells them both that you have to be employed and graduated within the last 2 years. It's up to you how you want to do it. The logic is, I think, probably simpler if you use and to avoid nested ifs if you can. So here's our example, right? If you're employed, yes. If you're a recent grad, yes, print, you qualify. Else, you're not a recent grad, but you really are employed, you must have graduated within the past 2 years. So one of those 2 things is going to happen if we are employed, but if we're not, we drop all the way down to here and we print, sorry, you must be employed to qualify. So if this part's true, the inner block is true, the nested if is evaluated and one of these 2 things happen. If this part is false, then it jumps down here and does that. The if, else, if. This is if you have multiple things that might be true, right? Case 1, case 2, case 3. You test a series of conditions. It says this is often simpler than using nested if-else statements. Okay, I'll accept that statement. I won't argue with it. Can be used to model thought processes such as, if it is raining, take your umbrella, right? We could indent that. Else, if it is windy, except let's make it say else if, right? So if it is raining, take your umbrella. Else if it is windy, take your hat. Else, take your sunglasses. Like that. Guess you're not allowed to wear a hat when it's not windy. That almost seems backwards. If you were like, you know, before the 60s when when all men wore hats and lots of women did, then you were wearing a hat and it was windy, blow your hat away. But what do I know? So if the expression is true, do one statement or a block of statements. Else, if the expression is true, do another statement. And you can keep chaining as many else ifs as you need to handle all the cases that you need. Finally, if none of them were true, then you do one last thing, right? Now, if you have a sequence of if, else if, it's always a good idea. Oh, wait, this doesn't show the terminating if. It's always a good idea to end in an else, right? Always a good idea to end in an else, even if you don't think it's possible. And the reason why is just because you don't think it's possible, you may have made a mistake in your code. And so you wanted to print some kind of error message of none of these cases are true. It's just a hint from bitter experience. If you think all your if, else, ifs handle every possible case, you might be wrong. And if you did not have your else down here, then it wouldn't do anything, right? If I delete that else, but none of these were true, then nothing happens and I don't see the results of that. I don't know that something went wrong. So I strongly represent putting a trailing else there, a terminating else, even if you don't think it's necessary. Like this, what is your grade? Is your test greater than an A score, a 90? Yeah, print A. Else, is your test greater than B? Print B. Else, if your test is greater than C, print C. Else, if test score is greater than D, print D. Otherwise, if all of those things are false, your grade is an F. Now, I'll tell you, here's how, once you teach people OR, the OR statement, here's how they sometimes want to write it. And you don't have to write it like this. Again, I'm going to do it in Python just because it's easy to type, right? If grade is greater than or equal to 90, then print A, right? Should have put quotes around that. Else, if grade is less than 90 and grade is greater than or equal to 80, print B. Else, if the grade is less than 80 and I don't recommend doing it this way, and the grade is greater than or equal to 70, print C. Otherwise, print an F. Yeah, we could do D as well, but you get the idea, right? This works fine. It's logically correct, but I would just write it like this. I would take the first part of these out because it's superfluous. Of course, if your grade is not greater than or equal to 90, you know it's less than 90. So you don't even need that. And if it's not greater than 90 or 80, you know it's less than 80. So you don't need that, right? Both of these are the equivalent code. Logically, they do the same thing. But this is cleaner, right? And if you ever had to go back in and modify your code, like to allow people who make an 88 to get an A, sometimes I round up, like, 89s. Sometimes I round them up to an A. then I'd have to change both that and that. And if I missed it and only changed it in one place rather than both places, then the program would not work perfectly. Whereas if I only have it listed here, I only have one number I need to change. You know, make that 88 rather than the 90. Well, that makes sense. I'm going to go ahead and paste this into here. Once you learn and, you get tempted to use it when you don't need to. For example, like that, right? Except I'm going to replace these with the correct symbol. And of course, this should really be C out. But you know that, so I'm not going to change them. I'll just put a note. Note the above is not valid, C code. All right, let's go about 10 minutes more and we can take a break. I mean, unless somebody needs to stop right now, you're always free to say, hey, need a break. All right, so the trailing else clause is optional, but it's best to use errors, right? Here, they've got it so that if your grade's greater than an A, you get an A. If it's greater than a B, you get a B, and so on. And then they have a test here. If your test score is greater than equal to 0, you made an F. But what if your test was less than 0? They just call that an invalid test score, right? So they gave the F a range of 0 to less than 60, right? Or whatever the D score is. And then they tacked on a final else. Now, in this case, I'm comfortable just doing it like that, right? But in general, you always want an else. Flags. A flag is a Boolean variable that signals a condition, right? Like, is frozen, or, you know, is ice. If you have a temperature variable, you set it equal to 20 degrees, then you could do, you know, bool is ice is equal to temperature F less than 32, right? That's the freezing point of water. Strictly speaking, you don't need the parentheses. I kind of like putting them there. I think it makes it easier to read. You can leave them off though. All righty, I'll change my password later. I hope I remember. So, or you can do bool is ice is equal to that. This does the same exact thing because everything to the right of the equal sign gets done first, right? You have your equal sign here, so everything to the right gets done first. Is temperature F less than 32? If so, that evaluates to true, and then the equal sign copies it into that variable, right? So that's a flag. Is ice is a flag, right? So if is ice, see out, better melt the water first. Or whatever, right? So a flag is usually a Boolean variable, and it's set by some kind of Boolean expression up earlier. And the reason you do that is this expression might be really complicated. What if this is like 4 or 5 different checks? Because really, temperature F, ice only freezes at 32 if the air pressure is equal to something. And yeah, I think that's it. I think it's dependent upon air pressure. So you might have to check 2 variables, right? Or you might have to have a formula there. In which case, if this expression is getting long, it's better to have it as a calculation here, and then you check here. But honestly, people just usually do, right? If temperature F is less than 32. Right? Just whichever makes the code easier to read is probably going to be better, right? So I'll just say use flags if the same expression is going to be checked more than once. Otherwise, it's your preference, right? So if we were going to check to see if temperature was less than 32, 3, 4, 5, 6 times in my code, it's better just to set a flag, right? Because then if we need to change the freezing point of ice, or we need to calculate it based on its pressure as well as the temperature, then we only have to change one equation rather than change it, you know, every time we have that if statement. So a Boolean value can, a flag can also be an integer where 0 is considered false and any non-zero value is considered true. As with other variables and functions, it has to have an initial value before it can be used inside of an if for a while. Here's another example of a flag variable. Bool quit equals false, right? And then while quit equals false, needed to be a double equal, didn't it? Then let's see out the age. Let's add 1 to the age. And if the age is greater than 100, we're going to set quit equal to true. Or we could do this, right? We could say quit is equal to age less greater than 100, right? So if the age is greater than 100, we're going to stop because this will set this variable equal to true. And so the while statement is no longer accurate, right? Because we kept looping while quit is equal to false. This sets it to true. So this will count up to 100, but stop at that point. You could do the same thing like if you're asking for input, right? Enter test score or -1 to continue. I mean, to stop, to quit. I'm avoiding that just because I don't want to make our program require input. You already know how to do input. And if I add an input statement, then every single time I run it, we have to enter data. But this will, we can watch that age variable count up, right? It counted all the way up to 100. Logical operators. We've already talked about these. And I don't know why we're saying new relational expression is true if both expressions are true, right? What's that new word mean? And then the relational expression is true if either expression is true. If one side or the other is true, then the result is true. And means both sides have to be true. And not means the opposite of. You've already seen not equal. You can just use the exclamation mark to represent not, right? If not is ice, see how, okay, it's already melted. We could stick in, whoops, that's inside the while loop, and there's no reason to print that every single time. I'm going to get that out of there, right? So instead of saying while quit is equal to false, we could say while not quit. Like that, right? That'll keep running as long as quit is equal to false. And so here's some logical expressions to check. Unfortunately, the answers are right off to the side, so we're going to scroll that off. X is 12, Y is 5, and Z is equal to -4. We just have to remember that X is the largest and Z is the smallest. So is X greater than Y? Yeah, because X is the largest and Z is the smallest. Is Y greater than Z? Yes, it is. And means they both have to be true. Are they? Yeah. So the result is true. Is X greater than Y? Yes, it is. Is Z greater than Y? No, because Z is -4 and Y is 5. So -4 is not greater than 5. So that's a false. That's a true. They're linked by an and. And means both had to be true, but they're not. So that's a false. X less than or equal to Z? No, it's not, right? 12 is not less than or equal to -4. Or Y is equal to Z. Well, that's also not true. So we have a false or a false. Neither side is true, so the result is false. How about X less than equal to Z and or Y not equal to Z? Is X less than Z? Is 12 less than -4? Nope, that's not true. Is Y not equal to Z? It is true that Y is not equal to Z. So that's a true. And since this is an or, it means only one side has to be true, so that's a true. How about this one? Is X greater than equal to Z? Yes, 12 is greater than or equal to -4, so that's true. But then the not turns it into a false, right? Makes it the opposite. And so that's false. What I've done sometimes in the past is make a worksheet where people had to figure out like 20 different expressions like this. I don't know. I just hope you get the idea, especially if you've already had Python or another programming language. I'm sure you do. So if you're employed and you're a recent grad, then print you qualify for the special interest rate. Else, you must be employed and have graduated from college in the past 2 years. What's the difference between that slide and that? Oh, now we're checking for minimum income. Aren't we rude? We sure are picky. We make sure they both have a certain income and they have to have been employed for a certain number of years. Oh, I see, but this is an or. So if they earn enough or they've been employed more than the minimum number of years, they qualify. Otherwise, they don't. And what's the difference between this and this? If not, income is greater than min income or years greater than minimum years. We're using a not now, so that's flipped it. It's flipped it so that the failure message has to be printed first. Else we can print you qualify. Or we could have rewritten it so that we didn't use a not, we just used less than, right? We could have said if income less than minimum income or years less than minimum years, or excuse me, it should be an and there in that case. I'm not going to get into that unless they mention it in the book. There's a special law that says, it's a mathematical law. Maybe I'll write it out. And then we're going to take a break. If you have this, if not A or B, that's the same thing as saying if not A and not B. It's kind of some distributive property like for math, except it flips the or to an and vice versa. If you have if, and you would need the real parentheses outside here as well, right? But I'm just leaving it off for clarity. You would need your parentheses like that. So if you have if not A and B, and there's a name for this law, and I always forget what it is every semester. then that's the same as saying if not A or not B. Let's see if we can come up with an example of that. Well, I guess that income is a valid way of doing it, right? If not, let's do our sick and tired one, right? Bool sick equals true, bool tired equals false. We get to stay home if we are sick or tired. So if we're not sick or tired, then see out, go to work, right? Because if we're sick or tired, we get to stay home. So not sick or tired means we have to go to work. Or we could use this expression, this way of changing it. So we're going to change it so that the or becomes and then distribute the not symbols to both of them. If not sick and not tired, because if we're not sick and we're not tired, we have to go to work. Which way do you want to write it? Either is fine, right? They both do the same thing. Whichever one is clearer to you. I kind of think that the more parentheses there are, the harder it is to read. So I might want to write it like that. But it just depends, right? It's entirely up to you. They both mean the same thing. All right, gang, let's take a 5-minute break and come back at 8:20. Any questions before then? We all good? Remind me to stop recording, to start recording, to resume recording. If I see this message on the screen when I come back, I'll remember it. So I've typed that mostly for myself. So Annie and Victor, any of this new material, is you already know all of it, which is often the case when people get to this chapter, right? Because you've already had beginning programming probably in another class. But hopefully we're squeezing some new stuff in as well. So logical notes. And has the highest precedence of anything. It's kind of like the minus sign if you're using minus sign in an expression like this, x is equal to 3 plus minus 4, right? That has to be done more quickly than anything else. It's called the unary subtraction. If the minus is being used in that context, it has to happen before anything else to switch that number to be negative, right? Not gets done before and an or. So that's why when you're writing your expression like this, everything else after it has to be enclosed in parentheses to force this to be done first. And when you write it like this, you know that that's going to get done first, and you know that that's going to get done second, right? And then it'll check the and. So the order of operations, also known as operator precedence, is that not is evaluated first. That was supposed to be an exclamation mark. And is next, and or is last. Just like multiplication is done before addition. checking numeric ranges with logical operators. If you got to check to see if something is in a range, you usually use and. If x greater than 10 and x less than 20, right? It's going to be inside that range. Usually use and to check if something is within a range. So our temperature F variable, right? If the temperature F is greater than or equal to 32 and the temperature F is less than or equal to 212, the boiling point of water, see out, the water is in a liquid state. Again, that's dependent upon air pressure as well and whatever, but you know, close enough. You usually use or to check if something is out of a range. So if something is outside a range, if the temperature F is less than 32 or the temperature F is greater than 212, right? Then see out, the water is not in a liquid state, right? It's either ice or it's boiling. Now, it is true that you could use a not to achieve the same thing. You could write it like this. If we wanted to say the water is not in a liquid state, we could do this. If not temperature greater than or equal to 32 and temperature less than 32, right? Then see out, the water is not in a liquid state. And I did put that exclamation mark in the wrong place, and so that's why it's underlined it with red over here. Let me move it to the correct place. There we go. Right. Now this is easy to read, isn't it? Like I said, if you can minimize the number of nots in an expression, the better off you are when you're trying to read it, right? Here's my silly little pun about it. Too many knots, you know, it will knot up your brain. So although this and this are exactly equal by the same law that we had up here, still wish I remembered what it was called. We were able to simplify it, or we could simplify it. Let me work through simplifying it. Do you remember when I said that if you took the minus sign off, then you could put the, if you put the not inside the expressions, then you could replace that and with an or, right? And so if temperature F is greater than or equal to 32 or not temperature F less than or equal to 212, then print the water is not in a liquid state. Now we're halfway towards simplifying it. We want to get rid of the nots completely, right? And to do that, we have to reverse the truthiness of this, right? Because that's what that means. And what's the opposite of greater than or equal? Less than. So now we can get rid of that not. Do the same thing over here. Flip that. And we say that. And now we're back to where we originally were, right? So just make sure that your expression works the way you mean, but consider rewriting it if it looks more complicated than that, right? I think this is easier. So that is more difficult to read. So if the grade is greater than or equal to 0 and the grade is less than or equal to 100, if it falls between those two numbers, it's a valid grade. So we used and to check to see if it's outside of the range. Now see that they've worded this wrong. They've made it so that a 0 is both a valid grade and an invalid grade. It should be if grade is less than 0 or grade is greater than 100, it's an invalid grade. So even people who write the books can get it wrong. But to check outside of the range, or to check inside the range between 0 and 100, and. Oh, and by the way, this doesn't work. Even though you learned this in school, you know, you can't do if grade is less than, you know, like that. That doesn't work. Can't write it like that. They had the equal signs, but even reducing, even eliminating them doesn't, because this being a binary operator requires both values to be numeric. So are they both numeric? Yeah, they are, right? But then this evaluates to either true or false. And so if that was true, then what is left? Is true less than or equal to 100? That doesn't even make any sense, right? We need two numbers to compare. So we can't word it like that. We have to word it in one of these ways up here. Menus. This is going to be part of Thursday's lecture. We're going to make a menu-based program. A menu-based program is when it offers you a list of choices. And then based on what the user picks, you do something. So menus can be implemented using if-else statements. So you might display a list of numbered or lettered choices for actions, right? Let's do something like that. We're getting close to the end, so I don't mind doing a little bit of user input. Let's take a number. Let's declare a number, just simple X. And let's ask them for a number. Let's ask them for that value. What is the value of X? Let's let them type it in. CIN greater than X. And now let's ask them what you want to do. So cout D for double it, H for half it, or S for square it. Right, so we have three choices. We need a variable to hold that choice. So string choice, and let's let them type it in. All righty, so if the choice is a D, then we're going to double the number, right? X equals X times 2, or just X times equal to, right? Either works well. Else, if the choice is equal to H, we're going to divide the number by 2. Oops, I need my quotes there, don't I? Else if choice equals quote H, X equals X divided by 2. Or you could just write X divide equal to. It means the same thing. Else, if choice is equal to S, then we're going to square it. X equals X times X, right? Or I guess we could write X times equals X. It does the same thing, right? And if all of these are wrong, if none of these are valid, that means that they didn't type in one of these choices, right? So cout choice is not a valid choice, right? All right, let's run it. Well, we didn't print out the answer. So cout X now equals, in quote, less than X, less than ENDL. And I goofed it up. Let's see what my errors are. Go to the error list. Empty controlled statement found. Is that the intent? Oh, yeah, that was not the intent. I say don't do this, but that's a warning, not an error. At least it gave me a warning. All right, let's try running it again. Well, then what's the error? All right, standard choice redefinition. Apparently I already had a a variable called choice. So I don't need to redeclare it, right? Now we should be good to go. All right, what is the value of x? X, we're gonna square it. So x times x, 10 times 10 is gonna be 100. But I'm gonna run it again and give it an invalid answer. Really, I ought to test it with every single one. You should always test every path through your program. So if there's an if statement, you wanna check it, see what happens both when that if is true and when it's not true. So this one has 4 different possibilities, right? It has doubling, halving it, squaring it, and invalid. And I chose square last time, so now I'm going to double it. 10 doubled is 20. Good enough. Let's run it again. And 10 halved is 5. And now we need to check the last condition, the final terminating else, right? The catch-all. What happens if none of the others are true? 10, but let's see. I'm going to type in, I don't know, R, right? And it says R is not a valid choice. So when you do a menu, you display the list of numbered commands and you prompt the user to make the selection and you test for the expression. Validating user input. You can check the input to see if it's valid, right? You can perform various tests. Like if you ask for somebody's age, their age better not be less than 0, and it's probably not greater than like 120. So you might reject output outside of those 2 ranges, or 130. I don't know what the maximum age of a human is. Check its reasonableness. Check to see if it's a valid menu choice, which I did, right? Or make sure that your divisor, your denominator, is not 0. So here's our test score. Enter your test score. Enter your test score, and I'll tell you what you made. Then they type in the score. And then we do some data validation. If the test score is greater than or equal to the minimum, and the test is less than or equal to the max, then way to go. We display the score, A, B, C, D, or F. Otherwise, we tell them that's an invalid score. Run the program again and enter a good piece of data. So that's input validation. It's just checking to make sure. Let's write that down. Checking to see if data is reasonable or valid. We checked the choice to make sure it was one of the menus, right? If grade is less than minimum or grade is greater than max, see out error message, right? And again, this isn't worded correctly. We'd have to use the parentheses and all that. I see a chat message. Wouldn't you use single quotes rather than double quotes? Very good question. Very good question. You would if we made it like this. If choice was a character. Then you would have to use single quotes. However, since it's declared as a string, you have to use double quotes around strings, even if it's just a single character long. If it's a character data type, you have to use single quotes no matter what, and it can only be 1 character long, exactly 1. But a string could be 0 characters long, it can be 1 character long, or it could be 100 characters long. So you have to use double quotes if it's a string. And if we looked up above, then when I made choice, it really was a string. Let's add that as a comment because that's a very good question. So in our if statements, we use double quotes to check the menu because choice was declared a string. You must use double quotes for strings, even if the string is just one character long. Does that make sense? Okay, good deal. Comparing characters and strings. Well, what do you know? One thing to note is that characters are compared using their ASCII values. If we go to ASCIItable.com, an A is a 65 and a B is a 66. So if we did if A is less than B, that would say that it's true. Is 1 less than 2? Yeah, it is, because a 1 is a 49 and a 2 with quotes around it is a 50. Now what's weird is that lowercase values letters have higher ASCII codes than uppercase letters. So a lowercase a is greater than an uppercase z, which looks crazy, right? If you wanted your songs listed, you wouldn't want the things with lowercase a to be listed after the z's. But that's the way that it would work if the programmers did not take some effort to fix that, right? Nowadays, people, I mean, you know, a program like an MP3 player is going to take that into account and fix it so that it works the way that people expect. But if you went to ASCIItable.com and we look, a lowercase z, wait, what was their example exactly? Yeah, a lowercase a is a, what's its value? A lowercase a is a, come on, zoom in. Why are you not zooming it? There, is a 97. An uppercase a, z, excuse me, an uppercase z is a 90. And so if you were going to arrange them in order, uppercase z comes before lowercase a. And so if you used an if statement, that's what would happen. It's just something to be aware of. Like characters, strings are compared using their ASCII values. So which one is greater than, Mary or Mark? Well, K comes before Y, so K, Mark, would be less than Mary. So the one that said that Mark is name 1 less than name 2 would be false because Mary is greater than Mark. So is name less than or equal to name 2? That's definitely false. Is name 1 greater than name 2? Yes, it is, because Y has a greater value than K. The conditional operator. This one looks weird. I'm going to go ahead and give you an example of it rather than show you the slide because I like the way that I explain it better. What if we have a string called result and we say result is equal to, is the temperature greater than 100? Wait, that was supposed to be a greater than sign. Is the temperature greater than 100? Question mark? Too hot. Colon, not too hot, right? Like that. Oh, that was supposed to be temperature F, right? Result is equal to, is age less than 18? Question mark. Too young to vote. Colon, old enough to vote. So to see the way that works, if this part is true, then the answer is the part before the colon, the first thing after the question mark. But if this part is false, then the second part is what's true. Now you don't need the parentheses. Again, I just put those there to be clear. That works, and that works. You just read it like that. It's an if statement. If this, then this, else this. It's an if statement written in a single line. So if int x is, wait, we probably already got x. Int a is equal to 2, b is equal to 3, comma, c is equal to 4. If a is greater than or equal to 0, colon, b plus plus, wait, that was supposed to be a question mark b plus plus, colon, c plus plus. What are the results all going to be? Why is that an error? Oh, because it's supposed to be just this, right? That's not an if statement. Let's remove these to make it look like a professional programmer would do it. I like the parentheses there, but the examples in the book won't have the parentheses there. So is a greater than or equal to 0? Yes, it is. It's 2. So this is the part that happens first. B plus plus happens. So B becomes 4. This doesn't change because that's the else. So since a is in fact greater than or equal to 0, b plus plus happens and b equals 4. The c plus plus does not. That's called the conditional operator. So question mark is called the conditional operator, especially if I spell. Some people call it the ternary operator, and I'm not going to write that term down unless the book uses it, because if you have an unary operator, which takes only one thing, like exclamation mark is an unary because it would flip the value of x from false to true, or the minus sign operator, which converts its operator to being negative or whatever. Those are unary operators, or unary. Almost everything else is a binary operator. Like if you do x is equal to 1 plus 2, that's a binary operator because binary means 2. It requires both parts. It requires an operand before it and an operand after it. The equal sign is a binary operand, right? Because it has to evaluate all that and calculate a value. And whatever that value is, in this case it would be 3, is one of the operands, and the x is the other operand, and the 3 gets copied into the x. So if x equals 1 plus 2, plus is the operator, 1 and 2 are the operands, right? X equals y greater than 0, question mark, 100 colon 200, right, like that. Question mark is the ternary operator. The conditional operator, 100 and 200 are operands, but so is this expression, right? Well, that's not making it too complicated. It was probably clear when I wrote it like that, right? Hope that makes sense. Let's go and look at their slide. So they're saying that if x is less than 0, question mark, y is equal to 10, else z is equal to 20. the switch statement. The way the switch statement works is, and if you've had Java or regular C or any language other than Python, you've seen it before. It's like a series of if-elses. And here, just like Anna said, since choice in this case is a character, they use single quotes around it. And the reason they made choice a character rather than a string is that I believe in this language, switch has to be an integer type. It has to be a number type. And a string is not a number, right? Because it's a sequence of characters. It's a sequence of things. Whereas a character really is a number behind the scenes, right? We've talked about that. You go to ASCIItable.com and an A is a 65 and so on. So the switch has to be based on a numeric type in this language, not Java. And then it just jumps to the right one. If you type in an A, it jumps here to the A case. It prints out that message and it breaks. What does break mean? It means it goes to the closing curly brace. But if they typed in a B, it jumps to the B, prints that out and goes to the curly brace, closing curly brace. If they type in a C, it jumps here, does that statement and go to the curly brace. And if none of them are true, it's just like that final else. It says you did not enter A, B, or C. So we could rewrite our program where we ask for the number. Where was that? Right? And we do our result. We could rewrite that using switch case. But to get it to work, I'm going to actually have to store the result in a character. So I'm going to create a new variable, right? So all I did is a copy and paste. What is the value of X? We let them type it in. I'm going to change this a little bit. So what is the value of X again? And then C out, double it, have it, or square it. But let's declare a new variable to hold our hold our choice. What are we going to call it? CH, I don't like that. Menu choice. And then CIN greater than menu choice. So we're going to change this to a switch case. So switch based on menu choice. Kind of like an old, Thomas the Tank Engine has a switch yard, right? And he goes, and the switch determines, which way he's going to go. And then there might be 5, 6, 7 different tracks leading away from that switch yard. I don't know if anybody knows who Thomas the Tank Engine is anymore. All righty, so switch based on that menu choice. Oh, come on. There. Case it was a D. If it's a D, then multiply it by 2 and break. Case it was an H, then we're going to half it. Got to be single letters. Single quotes, excuse me, apostrophes. So then we do that and break. Now the break statement is critical because if you don't have it, it'll do one and then the other, right? If I type in D, but there wasn't a break statement, it would multiply it by 2 and then divide it by 2. And if this break statement wasn't here, it would go ahead and continue and do that as well. That's called fall through, right? So you got to make sure you put your break statements. It's very, very rare that you leave out the break statements. Sometimes fall through is useful. And in our example on Wednesday, we'll probably do one that has fall through. But for now, let's just do the normal looking one. So in case of S, we're going to square it, right? Then we got a break. And then the default case. I forgot my colon here, so it's complaining. Looks like Python with the colons there. Anyways, you could put braces here if you wanted to, if you saw some need to. I wouldn't unless I felt like I had to. if I was declaring the same variable over and over and I had to redeclare that variable inside each one, then I might want to use braces. I would need to, but I don't. So, and then default, colon, print out not a valid choice, right? So that's the same way of doing the other one. And it's up to you which way you like better. You know, there's rarely a time when you have to use case. You like that one better than the if statements? I do. I'd rather implement it like that. To me, it looks clearer and more logical. If you think that this is clear and more logical, you are more than welcome to that opinion and to do it that way. So the choice is entirely yours. Just depends on which you think is more logical. All right. So the expression in a switch has to be an integer value or an expression that evaluates to an integer value, right? I mean, it could be x plus y as long as they were both integers, right? Or as long as it's a character, it works. And then all of those expressions, you know, case A, case B, case C, also have to be integer numeric values or characters. If no matching statement is found, if no matching value is found, then the program branches to the default. So just like you always want an else underneath all your if, else if, else ifs, you always want a default, even if you don't think it's absolutely necessary, right? Even if we thought we had validated our input to guarantee that the input had to be D, H, or S, right? We've already ruled that out somehow. But then what if our code that ruled it out didn't check to see if it was upper or lowercase, right? And then it would get down here and tell us that that's not a valid choice. But we could make it handle both uppercase and lowercase pretty easy. And this is pretty cool. It's one of the reasons why case is pretty cool. You could say in case of a lowercase d or an uppercase d, then do the doubling. Case lowercase h or uppercase h, do the halving. Case lowercase f, case uppercase s, do the squaring. Let's put some messages here. Let's double the number, \n. I don't know why I want to do this now when I didn't before. Let's half the number. And let's square the number. All right, I'm kind of liking this, and I think that we're going to turn this into part of an assignment. It's going to be a very short homework assignment. And the idea is that you're going to add 2 more menu choices. I for increase and D for decrease. Wait, no, D double, we've already used that. I'm trying to think of increment or decrement, but we've already used double. We've already used D, so we can't use decrement. We can't use decrease. Reduce. How about that? So I for increase by 1 and R for reduce by 1. So modify the code to add 2 additional cases, I and R, which should add 1 or subtract 1 from X. That makes sense? So that's going to be one of our 2 homework assignments. Let's go look at the other homework assignment. It's not too long, so don't think that I'm piling too much on you. Hope not. Pretty much we got a lot of people keeping up with the homework, which is pretty awesome. However, if we go and look, there's also a quiz waiting for us. Let's go look at everything that's waiting for us. If we go and look at the modules, Then week 4's got several different things coming on. But like I said, that homework is going to be really easy. Another video to watch, that's just 10 minutes of your life. So that's pretty easy. Except I didn't want data structures. I wanted a different one. Let me choose the one that I really wanted. Why don't I see it? Guess I just need to change the name of it. Forgot to change the name of it. Is that the case? So anyways, if you go to quizzes, you're going to see the chapter 3 quiz, which Anna reminded me was not posted. So it is there now. So we have an extra week to do it. There's also the chapter 4 quiz. So if you want to do it ahead of time, that's fine. All right. And so number 11 was supposed to say early programming languages, not what it currently says. So let me change the name of it. I had some good feedback. Some people liked these. I did give a little bit of extra credit here and there if people, you know, wrote a pretty thorough thing. So, you know, a couple of extra points here and there might always, you know, make you happy. Let's go and save that and then add that back to the module. And we'll look at the other thing, the homework assignment. And I forgot the words of crash course video for it. Oh, I'll fix that later. All right. So there's a video, 10-minute video to watch, and homework 5 and the chapter quiz for chapter 3. I don't think there's anything mysterious in it, but if you get stuck on something, you're always free to text. Remember that you can take these multiple times. Okay. So write a program that does the following task. Should just be task, not tasks. Submit the code and a screenshot as usual. Write a program to ask the user to enter the rise and the run of a right triangle. I need to, yeah. This is not accurate anymore. So I need to get rid of this PS. So ask for the height and the width, the rise and the run. And your program will use that information to calculate the angle, the length of the hypotenuse, and the area. No, it doesn't. Okay, let's get rid of that. So the hypotenuse is the long side of a right triangle, right? Sorry to give you so much geometry. Hopefully it's not too hard a problem. If you get stuck on it, it's fine. You're going to ask them for A and B. How do you calculate C? What is a formula for that? The hypotenuse is equal to the square root of the rise times run plus run times run. Excuse me, rise times run plus run times run. How do you take the square root? Well, if you've done use math defines and C math, you can just use SQRT. But in a pinch, if you didn't have the ability to do that, you could use POW to the half power. Because if you raise something to the half power, it's the same thing as square rooting it. So in a language like Python, where you use **2 to square something or whatever, if you did **0.5, it would take the square root of it. However, in C#, we have the square root function, so you're just going to use that, right? So that's how you get the hypotenuse to print it out. Here's how you get the angle. And here's how you get the area. I give you all the formulas, so even if you don't understand the math, you ought to be good to go. You just have to ask them for the rise and the run. And so to test it, if you make the rise and the run the same value, then it'll be a 45-degree triangle, right? If A and B are the same, it's a 45-degree angle. So that's easy to check. So I give you some test values down here. Test it with 10s. The angle will be 45 and the area should be 50 and the hypotenuse should be about 14.14. It'll be longer than that, right? But 14.14. And please, when you're done, submit the C++ code in a screenshot. All right, and so the next one, the really short one, hopefully it's really short, will be homework 6. And it's just going to be to take that code here. Let's add that there, even though it's not necessary, so that when I copy and paste it, it'll be okay. And then I'll remove that INTX there for the notes. All right. So the homework is modify the code below to support the I increase and R reduce menu choices. And then let's just paste that code in. So if we look at it again after I save it, we asked them for this menu. You might make the menu look a little bit better because it ends in a question there, right? And so it's not looking great. You can fix it if you want. And you're just going to add some cases, right? You're going to add some cases for lowercase and uppercase I and lowercase and uppercase R. So I really don't think that one's going to take you very long. And so we know what the break statement does. If it's left out, the program falls through to the next case. Switch is perfect for menu systems, which we just demonstrated, right? The user choose which one, and we use that as our test expression in the switch statement. More about blocks and scope. What is the scope of a variable? It's its lifetime. The scope of a variable is the block in which it is defined. The scope of a variable is within the curly braces in which it is defined, from the point where it appears to the end of the block. So if we go here, we don't really have very many blocks of code here, so I'm just going to make one, right? If, you know, true. It's going to do this all the time, right? Then if you have int a is equals 10, cout a, right? If you try to use that variable out here, it's an error. Can't do that. The line above is an error because AAA is defined within the curly braces above. So it is out of range. Another way to say that it is not in scope. Kind of like a rifle scope, you know, you're going hunting. If you don't see the thing in your scope, then you're not going to pull the trigger. If you're not in the same area with the variable, then it's out of scope. Hope that makes sense. If you wanted this variable to work here, you'd just move it up above, right? You could declare int AAA up here and get rid of that. And all of a sudden, this would work down here, right? Because AAA does exist, because it was declared above the curly braces. So it's in scope down here. It's in range here. I'm going to leave it like that. To fix the code above, you could declare AAA above the if statement. So if you need a variable that's valid anywhere in your code, inside any function in this C file, you could declare it up above all of your code, right? This is a global variable up here. Now, this variable is perfectly valid inside main. And if we wrote another function, see out whatever, right? It would be valid inside there as well. So global is valid for both of them. On the other hand, global variables are considered bad programming practice. Yeah, they can be useful, but usually you want to pass in that variable. Usually you would want to pass in that variable. And we haven't talked very much about functions, so I'll leave it alone. I'm just going to tell you that a global variable is one that's declared outside of any braces. So it is available, it is in scope, in range for every function in the file. However, they are considered bad programming practices. Just take that on faith until we discuss it again, okay? Doesn't mean you'll get, you know, the god of programming is going to come and smite you with a lightning bolt if you do it, but it can have unintended consequences and it can make your code harder to test. So there are reasons to try to avoid global variables. However, in my career as a programmer before I became a professor, I certainly did wind up using them. So it's not out of the question to use them. If you are going to use a global variable, you should stick it in a namespace. Something like this, namespace globals, like that. And then when you wanted to refer to it, like down in here, you could see out globals, colon, global variable, ENDL, right? That's valid. That's a better way of doing it. If you stick your global variables in a namespace, then you won't get what's known as variable conflict, which is when you define the same global variable in more than one file. Like if we added a new source file and we added another global variable with a name to match, that would be a problem. It would not compile. But if we stick it in its own namespace and each namespace is unique to each file, then we'd be good to go. So, two ways to do it is you can declare your variables up at the top of the function, or you can declare them close to where you use them, right? And so I could go and I could modify my code so that all the variables were declared up at the top of main, right? I could declare, you know, menu choice up here. I could declare my string choice, right? And all that, and then avoid doing it later on. But it's totally okay also to declare them kind of on the fly, close to where they're being used. There's either way is correct, right? If you think it makes the code clearer to list them all up at the top, go for it. One reason to do that is so that you could add comments, right? This would be the result of menu choice 2, right? And this is, you know, the result of blah, 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 right? So you could list all your variables up at the top, or at least the important ones, and then you could give comments as to what they were. Not a bad idea at all. This code is so scrambled and doesn't really solve any particular problem, so I'm not going to bother rewriting it so it does that, right? Often when I write these things, I like to declare my variable close to the point where it's being used when I'm writing sample code for students to look at, so that when you're scrolling up and down, you see, oh yeah, I know what choice is, or oh yeah, I know what menu choice is, that kind of thing. So I'm not going to revise the code to make this work. And now that I've added these two statements, I have compilation errors. Why is that? Because I have menu choice declared here. So if I scroll down to here, the variables have already been defined, and so it's complaining about them. So I better go and remove those, because you can only have the variable declared once. in a specific block of code. If you try to redefine it, it's an error. It's not like Python where you can say A is equal to 1 and then you can turn around and say A is equal to hello, right? You're only allowed to declare it once. You can assign as many different values into it as long as they're the correct type, right? I have to store ints into age. I can't suddenly turn around and store a double. It would get rounded down to be an int. And I certainly can't store a string or, you know, I could store a character, but it's just going to keep the value of it. Like if you stored an A into age, we've already looked it up. A capital A is a 65. So we would wind up with, you know, a 65 as age there. Because those are compatible types, because a character really is a number behind the scenes. All right, gang, let's go ahead and end it because I think we're done with the slides. Variables declared inside braces are called local or block scope. I don't use that term, but I use local. So everything in the program that I wrote is a local variable, except for that global variable up at the top. In this language, if you have a block inside a block, you can have variables with the same name. And what do I mean by that? If I come down here, I'm looking for that code that said if true. And then if I did this one, you know, another if statement, and I did string AAA is equal to whatever, this creates a brand new variable. And so I can't print AA out anymore and get 10. If I try to print AAA out here, it's going to print whatever. So it masks this variable. It hides it, but only temporarily. Because when we get to this closing brace, this variable disappears because that's the scope of it. So if I can put a comment here, the int AAA is hidden, masked, and only the string AAA is accessible now until the closing brace. That's generally a bad idea, and I don't do it on purpose. I never do it on purpose. And that's what this slide says as well. If you're inside a block within another block, you can define variables with the same name. When you're inside the inner block, the outer definition is not available, and it is not a good idea. And we are done with chapter 4. However, we're going to come back and talk about another topic here. I don't think it's fair just to, you know, cover a chapter a day. Maybe that's a little bit too aggressive. So we are going to do something else with chapter 4. We're going to do some more examples of switch and case on Wednesday, but then we'll go on and hit chapter 5. All righty, gang. Any questions? I think we're done, and I think all the folders are created. So we all good? All righty, I'm going to stop the recorder.